Okay, geometry students, in this video we're going to be looking at two triangles in great detail, okay? And the two triangles are called isosceles and equilateral triangles, all right? So with that in mind, let's go ahead and write your heading down for today, please. Your heading for today is isosceles and equilateral triangles. Isosceles and equilateral triangles, okay? The lesson number is 4.3. Be sure and include that in your notes today, and also include today's date, okay? Isosceles and equilateral triangles. Now let's go ahead and continue on. We're going to start by labeling the sides of an isosceles triangle. Now listen, students, remember, a right triangle has certain names for its three sides, okay? Well, an isosceles triangle does also, okay? So I want you to write this down. Please take some really good notes. In your notes, go ahead and draw an isosceles triangle, okay? Now, let's go ahead and label this side here and this side here as the two congruent sides, okay? And let's go ahead and call this triangle A, B, C. So we do have an isosceles triangle because we have at least two sides that are congruent, okay? So here's our isosceles triangle. Now, you need to know this, and please write this down. The two congruent sides are always called your legs. Okay, please don't forget that. This side here and this side over here are called your legs because they're the two sides that are congruent in the isosceles triangle. Now understand, these labels that I'm giving you, students, are labels that are only for an isosceles triangle, okay? We're not talking about any other kind of triangle right now, all right? So the two congruent sides of an isosceles triangle are called legs. Now the non-congruent side down here, we call this the base. Okay, students, and listen, it doesn't matter which way the triangle, go ahead and make note of that, please. It doesn't matter which way the triangle's turned, okay, are you listening? It can be turned this way. If the side here is congruent to the side here, this side right here sticking up in the air is still called your base, okay? It's the side right here is not called your base because the triangle is sitting on the side. This side here is called your base because it's the non-congruent side, okay? So the two congruent sides of an isosceles triangle are called legs, and the non-congruent side is called the base. Now, every base has these two angles on the end, okay? Please make note of those. Those two angles are called the base angles, and you need to know that, okay? These two angles here are called the base angles. And again, it doesn't matter which way the triangle's turned. The triangle could be turned like this, and here's your base right here. So this angle here and this angle here would still be your base angles, okay? Alright, so let's make sure we understand how to label an isosceles triangle so we know what we're talking about intelligently when we talk about legs and bases of an isosceles triangle, okay? Now moving on. Let's go ahead and jump right into this and look at our first theorem today. I'm going to pause while you copy this in your notes. You are responsible for this on tests and quizzes coming up, okay? Theorem 4.3. If two sides of a triangle are congruent, then the angles opposite them are congruent. Okay? I'll give you just a second to copy that down. It's not a very long theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. Okay? Please copy that in your notes. If two sides of a triangle are congruent, then the angles opposite them are congruent. Okay, go ahead and draw this triangle in your notes if you would, please. Copy this down. And then go ahead and mark this side here congruent to this side here. Alright? Let's call it triangle A, B, and C. Alright? Now, over here, write this. If AB is congruent to BC, then angle A is congruent to angle C. Let me show you how I know this, okay? Here's what this theorem is saying. if this side here in the triangle is congruent to the side over here, which they are, then their opposite angles are also congruent. So see this side right here, go straight across to this angle here, and see this side here, go straight across to this angle over here. These two angles are congruent. And how do I know they're congruent? Because this side here is congruent to this side over here. And what this theorem states is this: if two sides of a triangle are congruent, then the opposite angles, or the angles opposite them, are also congruent. So if I have two congruent sides in a triangle, then the angles across from those two congruent sides will also be congruent. Okay, hope that makes sense. Okay, take some really good notes. Let's continue on. Now write down this next theorem in your notes if you would, please. It's the converse of that theorem. I'm going to pause while you copy this down. And the last theorem said if we had two congruent sides, then the angles opposite them were congruent. This theorem says the opposite. It says if two angles of a triangle are congruent, then the sides opposite them will be congruent. Okay? So take a second and copy this down, please. This is the converse of the last theorem that we just learned, theorem 4.3. If two angles of a triangle are congruent, then the sides opposite them are congruent. Okay, now go ahead and copy this in your notes if you would, please, this triangle here. And when you draw this triangle, go ahead and mark this angle here congruent to this angle here. Okay? Now here's what we're going to put off to the side. Are you ready? Write this down, please. If angle A is congruent to angle C, then AB is congruent to BC. And here's how I know that. If I have two angles in a triangle that are congruent to each other, like these two angles are, then what you do is you draw a line straight across from this angle to this side over here, and draw a line from this angle straight across to this side over here. This side here must be congruent to this side over here. Okay? So let's look at it again for the third and last time. If two angles in a triangle are congruent, then the sides opposite those two angles are congruent. Okay? So I know for sure that this side over here is congruent to this side over here because these two angles were congruent. Okay? Now I'll give you just a second to finalize your notes here. I'll pause just a second, then we're going to move on. Okay, let's move on. Now, I want you to copy this problem in your notes, please, and I want you to solve for angle X. Okay? So wait a second while you draw this triangle in your notes. Draw a triangle GFH. Be sure and label this side here with a congruent mark, and label this side over here with a congruent mark, okay? And we are going to find the measure of angle X. Find the measure of angle X. Okay, here we go. Now students, look, we know from these little marks right here that this side here is congruent to this side here, and we just learned a theorem that said this: if two sides of a triangle are congruent, then the angles opposite these two sides are congruent. So I can take this side here, go straight across to this angle, take this side here, go straight across to this angle, and these two angles will be congruent. So if those two angles are congruent, then they have the same measure, then I know that the X, angle F or X, has to be 65 degrees, because this angle here has to be the same as this angle over here. Okay? Hope that makes sense. Let's go ahead and try another problem. If I'm going too fast, just have the supervising teacher pause the video, okay? Okay, moving on. Here we go. Copy this in your notes, please. Okay, now this one will be a little opposite, students. All right, notice we have an angle here marked congruent to an angle over here. So we have two angles in a triangle that are congruent. Now we just learned a theorem that said when two angles in a triangle are congruent, then the sides opposite those angles are congruent. So I can go straight across over to here. This side here will be congruent to this side right here. Okay, so this side here, put a little mark, is congruent to this side here. So I can say x plus 3 equals 12. Now bring the 3 over and make it a negative 3, and x equals 9. Okay? Let that sink in. We're going to move on. Not too difficult. Okay, let's try another problem. Here we go. All right, go ahead and copy this in your notes if you would, please. Copy this triangle down. Put 50 degrees right here. Put a y right here. And then be sure and mark this side here congruent to this side over here. All right. And here we go, students. You're probably working ahead. This is pretty simple math. It's not that difficult, okay? We've learned that if two sides of a triangle are congruent, like this side here is congruent to this side here, whenever two sides of a triangle are congruent, then the angles opposite those sides are congruent. So we go straight across to this angle, straight across to this angle. That means this angle here will be congruent to this angle here. So y equals 50. Okay, this angle here has to be the same as this angle over here. Okay, hope that's making sense. Let's try another one. Then we're going to move on to a couple more theorems, okay? Okay, you can work ahead or watch me. Again, this is pretty simple, so it's up to you. Please copy this problem in your notes. Be sure and mark the congruent angles here, and label this side over here y, and this side over here 9. Okay, here we go. Now, I know that this angle here is congruent to this angle here. Now listen, students, whenever two angles in a triangle are congruent, then their opposite sides are congruent. So you can draw a line straight across, arrow straight across to this side, and draw an arrow straight across to this side. We know that this side here will be congruent to this side over here, okay? So y has to equal 9 because these two sides are the same length. And we knew that because if these two angles are congruent, then the side that's opposite those angles has to be congruent. So this side here has to be congruent to this side here. So y equals a length of 9. Okay? Okay, let that sink in. We're going to move on in just a second, students. Not too difficult stuff. Now, copy this theorem in your notes, please. We have two more theorems to learn. This one and one more, and then a problem, and we're finished. Okay, that's it. Please copy this in your notes. Theorem 4.5. If a triangle is equilateral, then it's equiangular. Write that down, please. If a triangle is equilateral, then it's equiangular. If a triangle is equilateral, then it's equiangular. Now that's a big help, students. Okay, what that means is this. From now on, copy this in your notes, please. From now on, if I have a triangle like this, go ahead and put this in your notes, in which all three sides are congruent like this. Let's call this A, B, C. Here's what I know, okay? Write this down, please. If triangle A, B, C is what? Equilateral. Then I know that triangle ABC is also equiangular. So if I know all three sides are congruent, then I also know that all three angles have to be congruent, which makes them 60, 60, and 60, okay? So if a triangle is equilateral, then it's equiangular also, okay? Make sure you understand this. Okay, last theorem, write this down, please. If a triangle is equiangular, then it's equilateral. So this is the converse. This here is the converse of this theorem back here, okay? If a triangle is equiangular, then it's equilateral. Please copy that in your notes. If a triangle is equiangular, then it's equilateral. All right? Go ahead and and copy this in your notes, please. Draw a triangle like that, and then mark this angle congruent to this angle, congruent to this angle, and we'll call that triangle A, B, C. Okay, I'll come over here and write this down. If triangle ABC is equiangular, then triangle ABC is equilateral. Alright, there we go. So do you understand what this is saying, students? This is a big help. If we have an equilateral triangle, then we know it's equiangular. And the converse is true. If a triangle is equiangular, we have three congruent angles, then it's going to be equilateral also. So we know all three sides are congruent, okay? We know that because it's equiangular. Now, having said that, let's take a look at our last problem, and then we're finished for the video, okay? Please copy this in your notes, okay? Copy this down. Draw a triangle, RQT, okay? And then mark all three angles congruent. So put a slash in each angle of the triangle. And we're going to call one side 3x and the other side 2x plus 10, okay? Now here's what we know. We're trying to solve for x, okay? I want you to be able to solve for x. Well, students, think about this. We know that all three angles are congruent, so we know we have an equiangular triangle. But we just learned that if we have an equiangular triangle, then the triangle is also equilateral. So if this triangle is equiangular, which it is, then we also know it's equilateral, which means all three sides are congruent. That means this side right here, 2x plus 10, is the same as this side here, 3x. So we can take 3x and set it equal to 2x plus 10. There we go. Now simply solve for x. Bring your 2x over, make it a negative 2x. That's gone. 2x, 3x minus 2x is 1x equals 10. Divide by 1 if you want to, and x equals 10. Okay? So there we go. We solve for x. And by the way, that makes sense. If you put a 10 in for x right here, 2 times 10 is 20 plus 10 is 30. Put a 10 in for x right here, and 3 times 10 is 30. Both sides have a measurement of 30. Okay? Alright, so let's quickly review, guys. Alright, you need to be responsible for a couple of theorems here. So here we go. I want you to know that if two sides of a triangle are congruent, then the angles opposite them are congruent. And also you need to know the converse. If two angles of a triangle are congruent, then the sides opposite them will be congruent, okay? And you need to know that if you have an equilateral triangle, it's also equiangular. And the converse is true. If you have an equiangular triangle, then it's also going to be an equilateral triangle, okay? That's basically it, students. If you have any questions, don't hesitate to call or email.